guys, and welcome to Ken Campbell's Chemistry Series, presenting episode 2, topic Principle of Chemistry Part 2. The things we should cover in this episode: osmosis, Brownian motion, and changes of state. So osmosis. Osmosis is a very special case of diffusion. Osmosis is the overall movement of water molecules through a selectively permeable membrane, from where water is at a higher concentration to where it is at a lower concentration. Remember what we learned in diffusion? Diffusion takes place in both water, or diffusion takes place in both liquid and gases, and it's a movement of particles from an area of higher concentration to an area of lower concentration. So the only difference is osmosis is selectively. So it depends on the scenario for a certain in a case diffusion to take place. So it's like a special kind of diffusion. So if we look at the diagram, we can see that it does display diffusion as we learned before. It's just that there is something called a semi-permeable membrane that does the diffusion work. So it basically decides if the water molecules move out of the substance or in the substance, depending on the scenario. So in this scenario now, there's a higher concentration of water particles than of here. So the selective permeable membrane here will allow the water particles to move into this area because there's a lesser concentration of water than here. So this process will continue until there's an equal amount of water particles on both sides. That is how osmosis works. Now we're looking at an example of osmosis. So osmosis is demonstrated using thin strips of papaw fruit placed in distilled water or sugar concentration. The contents of fruit can be thought of as a solution of different substances in water. The cell membrane is selectively permeable. So in experiment A, the papaw strips are placed in sugar solution. As you can see, there is lower concentration outside the cell and a higher concentration inside the cell. So osmosis, which is the movement of water particles through a selectively permeable membrane from an area of higher concentration to lower concentration, the water inside the cell will move out into the sugar solution, leaving the papaw strips to shrink. While papaw strips in distilled water now, the outside would be a higher concentration of water molecules, and in here would be a lower concentration. So what would happen is the water particles from outside the cell will move into the cell from an area of higher concentration to an area of lower concentration through the selectively permeable membrane. So this is explaining it now. So in distilled water, the strips become longer and more rigid. This is because the water outside the cells is more concentrated than inside the cells. Water passes into the cells by osmosis. In the sugarcane solution, the strips become shorter and softer, flaccid. This is because the water outside the cell is less concentrated than inside the cells. This is because there is sugar as well as water in the solution. Water passes out the cell by osmosis. Now we're at Brownian motion. So Brownian motion is the random movement of particles suspended in a fluid, a liquid or gas, resulting from their collision with the fast moving atoms or molecules in gas or liquid. So this is a picture of how Brownian motion will operate. So an example. So a simple modern version of Brown's experiment is a smoke cell. A small cell of air is placed under a microscope and illuminated strongly from the side. Some smoke is blown into it. This motion is due to the collisions of invisible air molecules with the much larger particles of smoke. So the smoke is inside with the air particles, and we can see the zigzag paths of the smoke particles constantly bumping into the particles of air. This is just proves the kinetic theory of particles, in which particles are at constant movement, whether solid, liquid, or gas. And Brownian motion is a simple but a very explanatory experiment in which we can undergo to see the movements of particles. So the smoke particles are larger than air particles. That's why we can see the smoke particles better than the air particles. As you will learn later, gas particles always move at high speed in random directions. The same thing is happening to the air particles. When an air particle bombards a smoke particles, the smoke particle moves to the same direction as the air particle that hit it. When another air particle hits the smoke particle, it changes its direction of that second air particle, and so on. This is called Brownian motion. So what will happen to the small black particle and the large blue particle when they collide? And this is how Brownian motion works. It changes direction by the continuous bombarding of several particles of air or liquids. So we're at the changes of states now. So this is a diagram of how it would operate. So from solid to liquid, the particles will be melting. From liquid to gas, the particles will be boiling. And at this point, this is the last state in which most particles of most substances can exist. And when it reaches at a cooling, or it starts to freeze, then condensation occurs, and then it's back to liquid. Then it gets cooler, and the particles move closer together and gains enough energy to form strong bonds between the particles until they freeze back to solid. And this is how the process is done. However, in some cases, the substances of solids may not go to the liquid state but go straight to the gas state, and this gaseous state, and this is called sublimation, whereas it doesn't go to the liquid state but it goes from solid to gas, or gas to solid. And an example of a substance that operates like this is carbon dioxide. So carbon dioxide can exist only as a gas and solid, and the solid we know as dry ice. As it starts to gain energy or starts to get heated up, it quickly defrosts and move to a gaseous state. So guys, this is the end of the video. Please like the video if you enjoyed it, and share it with friends who really need this video, and don't forget to click that subscribe button for more videos like this. Bye.